Hello and welcome to Chapter 3 on manufacturer specifications for the 46RE transmission. In this chapter we will cover mechanical specifications, clearances, and adjustments for this unit. My name is Keith Clark and I'll be your host for this chapter. It's a great day to fix transmissions, so let's get started. Unit torque specifications are very important for proper operation of this unit, especially the valve body. Always use hand tools to assemble the valve body. Apply thread sealant and to the extension housing bolts as shown. These bolt threads are exposed to transmission fluid. All 46RE series applications have the same internal gear ratios. Planetary design and pinion count varies based on application. There are two end-play selective washers in the front portion of this unit. The first selective is located on the back of the stator. It is a fiber or plastic washer. There are 4 different thicknesses available. This is the final end-play check and adjustment to make on this unit since the pump is the final component to install. Use a dial indicator or an H gauge and feeler gauges to determine the correct thickness washer to bring the clearance into specifications. Note that the final end plate check can only be made when the overdrive section is installed. There is also a selective thrust washer between the intermediate shaft and rear clutch. There are 3 selective washers available for this location. Use assembly lube to secure the thrust washer to the rear of the rear drum as shown. This selective washer also controls front end play. Gear train clearance is rarely mentioned in torque flight units, however it is just as important. Critical loop passages must remain aligned. To check gear train end play, assemble the front planetary components, including the retaining snap ring onto the intermediate shaft. Invert the gear train and measure the clearance between the rear ring gear and the intermediate shaft as shown. Selective snap rings are available to adjust the clearance within specifications. Aftermarket manufacturers also make shims that can be inserted underneath the thrust washers to correct end play. Check your soft part supplier for availability for these selective shims. On the overdrive section, there is one selective end play adjustment. The selective spacer controls the overdrive section end play. It is located between the output planetary and the intermediate shaft. There are 4 sizes available. This end play is critical. Excessive end play will result in overdrive unit lubrication related failures. Be aware that this end play is affected significantly with high mileage vehicles. Inspect the surface of the overdrive planetary housing, intermediate shaft, and spacer. Wear in these areas will affect this end play. Also inspect the overdrive housing output snap ring and surfaces. Perform the following to adjust the end play. You will need a bar gauge and a straight edge as indicated in the illustrations. First, position the extension housing so that the output shaft is hanging free in the case. Insert the bar gauge, Miller tool number 6312, into the overdrive planetary sun gear until it bottoms on the overdrive planetary housing. Set up the straight edge, Miller tool number 6311, and the dial caliper as shown in the diagram. Measure the distance between the bar gauge and the surface of the Miller tool 6311. Compare the readings of the chart to get the correct selective spacer to use. Note that you can make your own tools for this procedure as well. We provide you with the dimensions needed to do so. The rear clutch clearance depends on the vehicle application and the number of frictions and steels. Ensure that you use the thin frictions that come in the overhaul kit. Make certain the Belleville spring, spacer, and wave snap rings are properly assembled in the rear clutch housing. Install the clutch apply plate first, then alternate friction steel as shown in the diagram. After the final friction is installed, the pressure plate and snap ring. Make sure that the snap ring is fully seated to the top of the snap ring groove. Measure the clutch clearance between the snap ring and the pressure plate. Adjust by changing the selective snap ring. When assembling the front clutch, ensure that you use thicker clutches in the kit. Depending on the clutch count, measure the clearance and adjust within specifications. The snap ring that secures the pressure plate is waved. Clearance is measured between the high spot of the waved snap ring and the top of the pressure plate as shown in the diagram. When assembling the Overdrive direct drum, it is important to note that there are 4 different size drums. Each of these drums can have one of 2 setups. To determine the stack that you require, there are a couple of important things to understand. First, the distance between the top of the drum, marked A, to the top of the snap ring groove, marked B in the diagram, determines how many clutches are used. The chart breaks down the clutch stack based on what design pressure plate and steel combination you use relative to the sizes. For example, if your drum has a measurement of 100 thousandths from distance A, well, the distance from A to B as indicated, and we have a second design pressure plate, then this clutch stack will require 10 friction elements and 9 steels. The pressure plate C determines the thickness of the steel plates to be used. It is important to keep all proper steel plates with the correct pressure plate. Refer to the chart for these measurements. The 48RE uses 90 thousandths drum with the second design, the 85 thousandths pressure plate, but it uses 23 single-sided clutches. There is no actual clearance check to make at this point. If the clutch steels and pressure plates are mixed or mismatched, the measurement for the correct overdrive selective washer will be out of range of available OEM shims. So let's look at the procedure for selecting the correct overdrive selective washer. The overdrive selective washer sets the clearance for the overdrive direct clutch release and the overdrive brake apply. It is critical to set this up correctly. Too little clearance causes a bind up on the 3/4 shift. Too much clearance causes a flared 3/4 shift, possibly slipping or no reverse. There are a few techniques that you can use to select the correct shim. Let's look at the factory method. You will need a depth micrometer or a slide caliper and a straight edge to perform this procedure. Set up the overdrive housing as shown. Ensure that the output shaft is allowed to hang free. Set up the straight edge and caliper as shown. Leave the bearing and selective washer off of the overdrive hub. You will need to measure from the straight edge to the surface of the overdrive direct hub. Repeat this measurement 3 more times in 3 different locations 90 degrees apart. Or if you use the clocks, basically we're going to measure at a 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock positions. Record each reading. Now it's time for some math. We need to find the average of these readings. Using this formula where we just enter the readings, we're going to add up all of our readings, and then we're going to divide that number by 4. Next, we take the average and we subtract the thickness of the washer. Now, say for instance, once we make all this measurement, we end up with the final measurement of 1.316, in the example that we're using here. Then we can select a thrust washer or a shim that's going to set up our clearance correctly. Our measurement of 1.316 references us to use a shim that is going to measure a thickness of 168 to 170 thousandths. There are 10 OEM selective shims available. You can purchase a shim kit that includes all of the sizes shown here. There are also aftermarket shims available. Refer to your saw part supplier for availability. Once the correct shim is found, secure the shim to the overdrive piston and the bearing to the overdrive direct hub using assembly lube. We recommend to use the torque method when adjusting bands. To adjust the front band, loosen the outer lock nut, then torque the inner adjuster to 72 inch-pounds. Once tightened, turn the adjuster counterclockwise the number of turns specified on the chart based on the unit that you're working on. Tighten the outer lock nut while holding the inner adjuster in position. Torque the lock nut to 30 foot-pounds. To adjust the rear band, loosen the outer lock nut, then torque the inner adjuster to 72 inch-pounds. Once tightened, turn the adjuster counterclockwise the number of turns indicated for your application in the chart. Tighten the outer lock nut while holding the inner adjuster in position. Torque the nut to 25 foot-pounds. Chrysler recommends using ATF plus 4 for the 46RE series transmission, especially in the 48RE units. ATF plus 4 is considered a synthetic blend fluid and tends to be more resistive to breaking down in extreme operating conditions. Use the service fill charts to bring the fluid level to the safe range. Follow procedures outlined in the service section to bring the unit to correct operating level. There are several opportunities for pressure testing of these units. It is recommended to use 2 gauges to compare pressure differences. Note that there is no dedicated line pressure tap. Accumulated pressure can be used for all forward ranges. Use the reverse servo tap for the reverse pressure. It is recommended to always use a scanner and pressure gauges to diagnose problems quickly and accurately. Use this chart along with scan data to help you. If you have access to a flow meter, you can check the flow efficiency, the cooler flow efficiency from cold to hot to ensure that your system is performing correctly under all conditions. Some transmission coolers inside the radiator can start to restrict when the coolant is under pressure. An acceptable flow rate of 0.8 gallons per minute cold to 1.5 gallons per minute hot should be common for 46RE series transmission operating in drive range. This will conclude our chapter on manufacturer specifications for the 46RE series transmission. We want to thank you for participating in our virtual training solutions powered by ATRA. Until next time, let's keep fixing transmissions together.